Intro, Gracias a 025. Visual animated Unix system overview with memory, file, and user components labeled. Narrator, how does Unix manage memory, store files, and even let users communicate with each other? In this video, we'll explore key OS concepts including swapping, demand paging, file system architecture, and user-to-user communication. Visual, display title, UNIX OS, memory management, file system, and user communication. Section 1, memory management, swapping and demand paging, 026 to 2 hello. Visual, diagrams showing RAM, swap space, and processes moving between them. Narrator, let's start with memory management, which is all about how the OS handles processes in RAM. Swapping. Narrator, swapping is the process of moving a whole process between main memory and disk when RAM is full. If a process is idle or low priority, it can be temporarily moved to swap space on the disk. Visual, show a process being swapped out of RAM and into disk. Demand. Paging. Narrator, demand paging is smarter. Instead of loading the whole process, it loads only the required memory pages when they're actually needed. Visual, only a few memory pages loaded on demand, rest stay on disk. Narrator, this reduces memory use and improves performance. But if too many pages are needed at once, it can slow things down due to page faults. Section 2, file system, blocks, fragments, inodes, 201, 430. Visual, file system layout showing blocks, fragments, and metadata. Narrator, Unix organizes data on disk using a structured and efficient file system. Let's break it down. Blocks and fragments. Narrator, data is stored in blocks, fixed size units, typically 512 bytes or 4 KB. But what if a file doesn't completely fill a block? That's where fragments come in, smaller subdivisions of a block used to avoid wasted space. Visual, visualize a 6 KB file stored as one 4 KB block plus 2 KB fragment. Inodes. Narrator, each file has an inode and a structure that stores all metadata, like file size, ownership, permissions, timestamps, but not the file name. Visual diagram of inode contents linked to blocks on disk. Narrator, inodes point to the actual data blocks on disk, helping the system efficiently locate and manage files. Section 3, directory structure, 431 to 520. Visual hierarchical tree starting from root. Narrator, Unix uses a hierarchical directory structure. Starting from a single root, every file and directory is accessible through a path. Visual Arduino, copy edit, plus, home, plus, user, plus, file.txt, bin plus, etc. Narrator, directories themselves are special files that store mappings between file names and inode numbers. Visual, show a file name linked to an inode ID. Section 4, user-to-user communication, 521, 630. Visual, 2 terminals side by side, simulating user communication. Narrator, Unix supports real-time user-to-user communication through various commands. Write command. Narrator, write lets you send a message directly to another user logged into the same system. Visual, SQL copy edit, or write Alice. Hi Alice, are you free for a quick call? Wall command. Narrator, wall broadcasts a message to all users. Visual, Ruby copy edit wall. System will go down in 5 minutes. Talk and mail. Narrator, for interactive chat, Unix provides talk, and for asynchronous messaging, there's mail. Visual, screens of talk chat window and inbox view of mail. Conclusion and summary, 631, 7 Alco. Visual, split screen summarizing 3 sections, memory management, swapping, demand paging, file system, blocks, inodes, directory structure, communication, write, wall, talk, mail. Narrator, Unix isn't just powerful, it's smart. With efficient memory handling, robust file systems, and built-in user communication, it's no wonder Unix still forms the backbone of modern OS design. Visual terminal fades out with the message, "Thank you for watching. Subscribe for more OS insights." Narrator, like, share, and subscribe if you found this helpful, and stay tuned for more deep dives into system programming.